Get ready, dental labs. Either Class Flash Sale is here. From November the 3rd to the 14th, you can score unbeatable deals on the equipment that will set you up for success in 2026. Whether you're upgrading your mill, your furnace, or expanding your workflow, now's the time to save big. And here's the best part. When you purchase a milling machine, delivery, installation, and training are all included, so you'll be production ready from day one. But hurry, these offers won't last long. Reach out to your Either Class sales rep today and don't miss your chance to power up your lab for the year ahead.
Welcome to Voices from the Bench, a dental laboratory podcast. Send us an email at info@voicesfromthebench.com and follow us on Facebook and Instagram. Greetings and welcome to episode 399 of Voices from the Bench. My name is Elvis.
399? Are you kidding me? It's like New Year's Eve for podcast. My name's Barbara. That's crazy.
The last of the 300s. Here's on to bigger and better things.
Right on. You should be celebrating. I'll celebrate with you. How are you?
I'm doing really good. So last weekend, was it last weekend? I don't know. Lab Fest 2025.
I saw your silvery, beautiful, awesome something that you were wearing. It was just like you. It was awesome.
Yeah, you know, I went on Amazon and I was like, I can't just walk out there with what I'm wearing.
What do you actually look up when you're looking for something like that? What'd you research?
What did I? Shiny jacket, I think. Might have been ugly in there, but it was.
I don't think so. I think you shined bright and it was beautiful.
It was nice.
And I loved it.
It was a lot of fun. I really enjoyed hosting the game show. Everyone really liked it. I don't think we really...
Oh, I bet.
It went too quick. Let's just say that. We had all these questions lined up. We had 40 minutes and we were done in like 26, 27 minutes.
So next time, now you know you can do like
now we know.
Rounds, 3 rounds.
Yeah, but it was a lot of fun. The whole show was absolutely amazing. I mean, some of the best speakers I've seen in a while. Everybody that was anybody except for you, Barb, was there.
I was on a crazy-ass dysfunctional family cruise, for those of you that are listening.
Tell me all about that. How was it?
No.
Are you all still friendly after it? Whew. Enough said. Moving on. Back to LabFest. Sean and Brandy, Mary Beth, that whole team at NOAC. What a great job. That riverboat cruise, you know, not only was it just like a cool idea, what really, really was amazing is how many people dressed up.
Everyone dressed up.
Almost everyone. There were very few that didn't. And that really goes to show the level of attendees that go. You know, I mean, everyone's participating.
Everyone looked like they all had it going on. Brandy, somebody must have told all the females where to go to find the most amazing outfits. Because everybody had headbands on and these beautiful outfits. The guys looked amazing, but I'm a female, so I was looking at the dresses. But it was so amazing.
They did such a great job. And of course, thank you to Adite for having us out there. I was next to them. It was just a lot of fun. Thank you so much, Adite, for allowing me to record. I didn't get a ton of recordings, but I got a really good one. So
you said you got long recordings because
you weren't there.
You, and you were like, "Well, you told me." I said, "Hey, how you doing?" You said, "I got 2 really long recordings, and I'm having a whole lot of amazing times with people." And that was only the one time I hit you up, but I'm sure you got more than that. So thank you, Adite, for sponsoring Elvis.
Yeah, one of those conversations might be over an hour, but...
No, not
you
with
weren't there,
you.
Barb. You
not with
there.
me to say, cut it.
But after the show, you know, the government was still shut down, and travel was not great.
I got stuck in the airport for 10 hours trying to get home.
10 hours?
Yep.
So on my way home, I was going from New Orleans to Charlotte to Indy.
Yeah.
They delayed the first flight once, twice, 3 times. I was going to miss my connection, but then they delayed my connection. So I got to Charlotte, and they delayed. And at 2:30 in the morning, they decided to move it to 5 a.m.
So you stayed in the airport?
I slept on the airport floor for the first time in my life.
Ugh, I'm with you, man. That was tough.
5 a.m., and I think I got home at 7, 8 in the morning when I should have got home back at 11:30 the
You're
night
a
before.
superhero. Like, that was crazy.
It was a mess. There were so many people, their flights were canceled. They just rented a car and drove home. I know so many people that did that.
I try not to talk politics, but that was bullshit.
Yeah, well, politics aside, air travel's air travel. I mean, not good. But still, looking back at it, totally worth it. I'd sleep on an airport floor again just to go back to another lab fest. I tell you. So, we have talked to a ton of people in this industry about design software.
Yep.
We've talked to people that make mills.
Yep.
And of course, we have talked to countless people that make zirconia. But what about that CAM software that's part of this workflow? You know, the magical program that tells your mill to make what you design.
What to do? Yeah.
Yeah. Well, there is some pretty smart people behind that software. And this week, we got to talk to Jordan Greenberg from Follow Me Technology, better known to the rest of us as HyperDent. Jordan talks about growing up in a dental family and actually starting a milling center with his technician father years ago. After working with one of the first machines to mill titanium, Jordan met some German folks at Follow Me Technology and was soon running their North American division. Jordan takes the time to break down exactly what CAM software does, which is nice.
I know. Huge, right?
Some challenges HyperDent has been able to overcome, like direct to multi-unit milling, and how little tweaks in your CAM can help you produce better restorations. So join us as we chat with Jordan Greenberg.
So we're still a couple weeks away from our episode with Jordan Greenberg, the HyperDent dude from Follow Me Technology.
Yeah, we are. I actually ran into him in New Orleans at LabFest. My God, tons of attendees were really picking his brain. It was refreshing to see that both lab owners and technicians have identified CAM as a potential area for improvement for their labs and milling centers.
Well, you know, Elvis, us lab techs, we're tinkerers. And it seems like CAM is the tool that allows for us to tinker with our milling results, right?
You know what? I think you're right. So I overheard a few conversations at LabFest about that. And I learned that there's a feature included in every HyperDent license called Template Editor Lite. Now, it's not their full-blown template generating tool. That would be a little too much. But it gives their users the ability to make small, yet safe, changes to their milling results.
Oh, cool. And do tell, how does that work?
I don't know. You know better than to quote me on this, but some of these conversations went into a ton of technical depth. But from what I understood, there's a predefined range of milling strategy adjustments available to the user.
But I thought Jordan said they did all the template validation themselves in their New Hampshire Tech Center.
They sure do, right there in New Hampshire. Who would have thunk? That's exactly right. But this is all part of their development efforts. So basically, as an example, the user can make adjustments to prioritize surface quality over speed or vice versa. Or they can make small adjustments to satisfy their fit preferences for every restoration type.
Oh, wow. It's like choose your own CAM venture.
Good one, Barb. That's hilarious. That's the funniest thing you've ever said.
I try. I can hardly believe 2025 is almost over. As the end of the year approaches, dental labs everywhere are feeling the rush. Schedules are full, deadlines are tight, and there's absolutely no room for error. So that's when dental professionals lean on the one thing they can rely on most for productivity and reliable milling solutions.
You know, every December it's the same story. Long hours, high volume, and zero room for mistakes.
Yep.
But with the Roland DG-shaped mills, we know that we can count on consistent results. The DWX53DC is a workhorse with 24-hour automated milling. It's like having another technician on your team. It keeps our lab running while minimizing our overhead and maximizing ROI.
Exactly. Reliability means profitability. Everybody knows that. And when our mills run smoothly, we stay sane and on schedule and profitable. No redos, no downtime, just precision and on-time case deliveries. And that's no accident. Roland's long-standing reputation for quality is built on Japanese engineering and craftsmanship. It's a legacy of meticulous design and unmatched performance. Every spindle, every detail, every calibration reflects decades of refinement. It's not just about technology, it's honestly about trust.
I've tried other systems and nothing beats our Rolands. They just keep going. They are the workhorse that never quits.
Honestly, Elvis, it's the MVP of milling, especially when you're racing to wrap up the year strong and there aren't enough hours in the day.
This season, when precision and reliability means everything, choose the solution that's proven to deliver. Choose Roland's DG Shape, the workhorse of dental milling. Crafted with Japanese precision, the most trusted brand worldwide. For more information, visit RolandDental.com. Voices from the Bench. The interview. So Barb and I are super excited today because we have a guest on that has probably been in the works of getting him to come on, I'm going to say about 6 years, maybe 5 years.
Oh my God.
Yeah.
Oh boy.
Jordan Greenberg, how are you, sir?
Hello.
Hey guys. Doing very well. You finally caught me, huh?
Yeah, no kidding. I got to tell the story because I was with Preet and I was at Roe Dental Lab, just kind of visiting. They're in my territory, and you were there, and y'all were working on the cam aspect of, I think it was milling abutments. Was that what it was doing? I think.
I'm not sure what we were doing. It might have been some fancy full art stuff that we were up to when we were visiting at that point.
Yeah, but it was like fascinating to me because, I mean, we're going to get into all this, but it's like the cam side of it. I don't think we've really talked to anybody on this podcast about it. And
we definitely haven't.
I just put things in a machine and it does it for me. So we're going to get into all of that. But Jordan, let's find out about you first. Who are you? Where do you come from?
Who am I? So,
who are you?
Similar to the majority of the people you probably talk to, I'm just another dental nepo baby. I was brought into the industry from my dad. He was brought into the industry from his dad, who was a dentist. He had a dental clinic. My dad started his lab in the back closet of his clinic.
Oh, really?
That's exactly right.
Fascinating. Really?
You know what? I meant to shoot him a text and figure out how long ago this was before I hopped on, and I didn't. So
you didn't do your research? We didn't either.
I didn't do my homework. Sorry. But congratulations to him. He actually recently retired. So he and my mom, who was his office manager, along with a small handful of employees that he had over the years, they closed up shop a couple years ago. They're down at Florida now. He's playing pickleball. She's doing water aerobics. So they're having a great time.
That is amazing. That's the dream story, man. Run that lab, work in small business, doing what you want to do, and then retire and where you want to retire.
That's exactly right. But they, to answer your question, were up in Chicago. And after college, when I didn't have too much direction at that point, or I didn't have any definitive decisions that were already made, he started to show me some of what the digital aspects in dentistry, where they were at, which was obviously quite early on in the works at that point, right?
Yeah.
He actually showed me a zircon machine, which was one of the earliest zirconia milling.
Big time.
Took to that like a duck to water, if I want to pat myself on the back, and said, this stuff's pretty cool. It's interesting. So we started a separate business, a small milling center in order to produce high quality restorations in zirconia, which at the time were really just copings for dental labs in the area. So in the Chicagoland area.
Hold on. So your dad was a lab and his dad was a dentist?
That's exactly right. Yep.
All right. So he was running a lab and brought you in and said, check all this stuff out. And you just went, ding, I love it. And that was it.
Yeah, it was really cool stuff. Got super involved and interested in it. So we went shopping for our own milling system. We hopped onto the Cavo bandwagon, which was a little different than some of the other offerings at the time. It offered a super high-end final product as opposed to some of the other options out there, most notably the lava solutions.
Okay.
Oh, yeah.
Interestingly enough, I guess we'll call it a fun fact, both of those machines, the lava machines at that time, which was around 2006, and the Cavo Everest system, which is the one that we adopted, they both use toolpaths that are basically what HyperDent is today. It's the company that preceded HyperDent. It's called Open Mind Technology, and their product is HyperMill. And they cater to just the general CNC machining world, not dental specific. So my life has sort of come full circle in that regard as well.
So what was that mill called? Cable? What? I've not heard this.
Cavo. So maybe the Germans
I've
pronounce
heard of
it Cavo.
Cavo.
Yeah, Cavo.
Sorry, I was misunderstanding.
Cavo? Cavo?
Yeah. Okay, sorry, I was misunderstanding. Yeah.
Yeah, no, that was a cool system, and it was all inclusive. It included the scanner, the design software, and the machine, plus the sintering oven. And it was a little slower. It was a little less of a high production mill compared to the lava systems out there at the time, but it really did a beautiful job. Super thin margins, no chipping, no cracks. Had a pretty successful run in that regard when we were using that equipment in terms of the quality we were getting off of it. And again, we were only doing copings at the time, getting $89 a pop, by the way, which was pretty cool.
Yeah,
pretty damn good.
I can't even get
Right.
that for a finish ground these days.
Yeah, right.
Were they as big as the
No.
lava machines and as expensive?
They were a little cheaper.
Yeah.
I think Lava was kind of charging a little bit for the equipment and a little bit for their name recognition.
Yeah.
Because at the time, I mean, it wasn't a zirconia. They got everyone, just like we asked for a Kleenex instead of a tissue. Everyone was asking for lava crowns, right?
Oh, yeah.
A zirconia crown is exactly what it was that they wanted, or a zirconia coping, mind you. But yeah, we had to do a little bit of work in terms of explaining what it is that ours were. They weren't officially or quote unquote lava crowns, but it's using just as quality of a material, potentially even a higher quality machine. And we got to do a couple cool things. I mean, even stuff today like hybrid restorations, tie bases, within a more complex understructure. We were able to do a lot of that stuff too with copy milling, of course, different techniques that we use. But yeah, it got us out the door up and running, and we were pretty happy with the results. I think our customers were
That's
too.
awesome.
Well, I'm sorry, but you flew right by seeing your first mill, and then all of a sudden you said we were out shopping for a new machine. So did you go into business with your dad? I mean, you were just right out of college. So did you decide right then and there that was going to be what you wanted to do? And if so, you said then you went and looked for machines. So like, did you develop a company, or like, were you in business with your dad?
One question at a time.
Yeah, we
Sorry.
started a separate business together. He was very supportive of me and in beginning that venture, and we started shopping for that machine just within months of me graduating college, playing around on his existing equipment, and then deciding that we wanted to collectively provide these services to labs within the area.
So you went in partnership with him.
That's right. Yep.
Fantastic.
Okay, so you
thank
got
you.
these mills. And obviously,
Sorry.
no, you're fine. And obviously, they come with their own. I always get these two confused. CAM software,
Right. Yep.
and it comes with. Okay, so this is where I need to get into this. So the CAM software it comes with. You said it came from Outside Dental.
It did. So it was, for all intents and purposes, invisible to the user at that point. The Cavo machine specifically had individual ingots of blinks in order for you to position in the holder in the mill.
Okay.
And they had RFID tags on them. You would scan the RFID tag, and the invisible, quote unquote, invisible cam code would associate itself with that blank, and then off it would go. So, ironically enough, I had my own first dental milling solution, and the cam wasn't even an element that I had any control over. And that's all I do now.
Yeah, that's what's fascinating to me. Okay, so you're running this milling center. How do you end up where you're at now?
So things started to slow down after a couple of our largest customers started to invest in some of their own equipment.
Sure.
And then me and my dad had a couple conversations and made the decision, especially when there was a new opportunity that came along for me to sort of up my game in terms of what it is that I did in the milling world. So we made the decision to close shop.
Yep.
And I hopped on a plane and headed over to New Hampshire and worked for a company, Datron Dynamics. And that was a provider of a pretty impressive milling solution that was able to do titanium bars and abutments directly out of a disc. So quite a jump from what it was that I was originally playing on.
So what drove you to that company? So what was it about it that made you close up shop and fly to New Hampshire?
So they were super ahead of their time. They were the first machine that was basically off the shelf, or plug and play, as you will, in order to purchase a milling system paired with CAM software, which is where I met the HyperDent guys, and then get milling with titanium bars, custom abutments, and more industrial type applications the minute that machine is installed. Traditionally, you'd have to source your own industrial milling equipment. You'd have to go get your own CAM software. You'd have to write strategies. You'd have to pick out tooling. You'd have to do all that work on your own. And you'd typically have to have a lot of experience or some sort of a degree in order to put all those pieces together. Datron and the D5, which was their flagship milling machine, our flagship milling machine, was the one that had those capabilities. And then we plucked all those pieces, put them together, and sold that as a complete solution to a lot of forward-thinking labs that wanted to do bars and other titanium, chrome, cobalt stuff within their own doors.
And what years was this? When did this happen?
That was, I should have done more of my own homework in order to give you quick, definitive answers, right?
Yeah, we like timelines, Jordan. Sorry.
I'm just trying to find out, it's like, was this one of the very first companies that allowed you to mill a bar?
This was 2012. I think it was May of 2012.
I was going to say, that had to be an early adapter company, man. You had to be like way ahead of the curve in 2012.
Oh yeah. It's awesome to know that we still have over probably a couple dozen customers out there that still have their D5s, and they're still chugging away making bars every day.
Wow. That's
pretty cool stuff.
A lot. Yeah. Okay, so you're with this company. You're selling metal milling.
Yep.
Where'd you go from there?
So I was the I don't remember my exact title. Something of a dental product manager. Because mind you, Datron is not just specifically a dental company, right? So I specifically was the dental product manager. I got a lot of experience implementing HyperDent as our solution that we paired with the machine, the CAM software with that machine. I chose it because of, number one, the ability for me to support our customers was significantly better and easier with HyperDent than any other CAM options. They had some tools, most notably the ones that were for the production of titanium bars or implant interface geometries. So I want to say maybe one customer had a alternative CAM preference. The other 49 or so, let's call them, all chose to pair their machines with HyperDent. So I naturally got the attention of the Follow Me group, who distributed and supported HyperDent in Germany. I got their attention enough where they came out and we had some discussions that led to me opening the North American branch office for Follow Me, which is the sales and support and development channel for HyperDent here in the US and Canada.
So you're a bad bleep. I'll say it for you, Elvis. That's pretty impressive.
Hey, I've heard some of your podcasts before. I don't know why you had the bleep. Just say it.
You're a badass, man. That's pretty impressive.
She was trying to save me a quick edit.
Yeah, right.
Explain to me, why is it called Follow Me? Because I noticed that on your email, and I'm like, how come it's not at HyperDent? What's the follow me?
That's a good question, and it's asked often. So just like let's take our CAD counterparts, ExoCAD, right?
Yeah.
ExoCAD is wait, hold on, I'm going to get this wrong now. So Follow Me is the name of our company. HyperDent is our product. ExoCAD is actually the name of their company, and DentalCam is the name of their CAD product. Everyone refers to us sort of backwards. Everyone calls ExoCAD by their company name. Everyone calls HyperDent or refers to HyperDent by the actual product name.
Interesting. Yeah.
Yeah. A little nomenclature lesson there for you.
Yeah, no, we appreciate that. So HyperDent existed how long before you came around? I mean, it was in other countries, right? First?
It was. So it originally branched off of a company in Germany called OpenMind. OpenMind's product was Hypermill, and Hypermill catered to all types of industries, mold making, aerospace, you name it. They developed CAM software, or at least they had CAM software that could cater to that specific general application. They got their feet wet in the dental industry, as we've already discussed, in kind of some of those early closed systems in which we didn't even know that there was CAM software or what it was or how it worked, how it interacted with the machine. But what generally happened at that point is that they started to recognize that the dental industry is not just a different segment of their business, that it's an entire company altogether.
Yeah.
It's
the business.
Different company altogether. Yeah. Sorry, yeah. So the product that stemmed off of our very free in terms of freedom, and someone who has maybe an engineering degree, but is highly experienced in machining and creating the elements within the CAM software. That's a different type of customer than a dental lab technician. So the product had to evolve significantly in order to make it quote unquote easy enough for a dental technician to use while still having the performance and the tool path generating capabilities of our sister product Hypermill. So yeah, that's a completely separate company that was started. Again, I didn't do my homework. I would say probably a couple years before I started or joined. So I think we just celebrated a 15-year anniversary.
Nice.
So you've only been around 15 years?
So Follow Me as a separate company has been
got
around
it.
for 15 plus years. We were involved in the dental industry for probably closer to over 20 at this point.
Wow.
And you were the first one to bring HyperDent over to the States in that metal mill?
I don't know if I could take credit for that.
Okay.
There were
one of the few.
We're one of the few, yeah.
Elvis wants you to take credit for that, though.
You could give me credit, but I believe there were a couple companies at the time, a few companies that have implemented HyperDent proper, the actual standalone CAM product, aside from some of those closed systems that already utilized it. So,
do you guys even have a rough estimate on how many mills that HyperDent is in?
Oh God. So we have something called a post processor, and it's basically something that translates just a generic tool path. Basically, trace this margin line, right? And it translates it into something that each individual machine can understand. It's almost like each machine's language, right? I do know we have over 200 post processors that are available. It's almost easier to talk about the machines that we don't or can't work in as opposed to the ones we can. Not that I'm going to name them. We can't give them any credit on your show, right?
Of course.
So, of course.
Yeah, of course. It's all good.
But yeah, there's just a small handful of closed systems that still exist that basically don't make the information of their machine, how it runs, the code it uses, or the kinematics, which is just generally how the axes move and how they relate to each other. They won't share that information with us because they have their own in-house solution, and we let them do their thing, and they let us do our open thing on our end of the world.
Love it.
How involved are you in that coding and all of that part of it to be able to talk about it and understand it? And how long did that take you? It's pretty fascinating.
So again, you guys are giving me a little too much credit. Our German counterparts usually work with the machine manufacturer in order to create that type of stuff. We do have our engineering manager here in North America, Mark Fisher. He comes from a machine world, also mixed in with some dental applications, but now he's Mr. Dental, of course. So he understands the nuances of how to build that type of stuff. how to speak that machine language. And he'll offer feedback to our German counterparts who would implement it into these post processors that they were just referring to.
Good explanation. Thank you. That made a lot of sense to me.
Sweet.
You got to kind of dumb it down for me when you talk about some of this stuff.
Hey, we're getting pretty
Elvis
complex
knows.
pretty fast. So
I'm about to ask you to let's break down exactly what HyperDent does. I mean, I started this whole thing saying I just put stuff in the mill and it just does it.
it's magic.
I don't know. It pretty much is. And I'm sure there's people in the industry that run the mills more than I do that maybe have a better understanding of it. But you're mentioning tools and paths. So break it down to a fifth grader, man. What does HyperDent do?
So yeah, in its most basic form, you have you take a scan, right? You replicate the real life situation in the patient's mouth. You design your restoration off of that. That's done in 3Shape, exocad, and a few other CAD programs in order to get that STL file along with all that other supplemental data that you probably ignore, but it spits out a lot of great information that we use in CAM.
Like what? I mean, other than the STL, what else do you need?
So you have margin line. I mean, just for a crown itself, right? You have an insertion direction. We use that so that our tool can go within the inside of that coping and not have any sort of undercuts remaining, even though you might tilt it to fit in the disc. If we milled it just from 0 and 180 degrees or just from the top or the bottom, then we would leave some material inside that crown. So that insertion direction tells the tool in which direction to approach the inside of the crown, so it doesn't leave any sort of undercuts remaining after it's milled out. Then it plops right down, right? So it tells us that. It tells us the margin line. We use the margin line because we like to be a little more careful immediately around the margin line. We have more conservative tool paths immediately on or near the margin line, as opposed to working your way up or around the crown. We could be more aggressive and save some time by milling the occlusion with a little more speed.
Interesting, yeah.
So yeah, I think we just skipped a bunch of concepts and went straight to the fun stuff. But to strip it back
fifth
down,
grader, man, fifth grader.
Yeah, what is CAM software? We really just drive the milling machine. So you have this digital design, and you need to translate it back to something that exists in the real world, right? And the design exists in 3D form, but you need a tool to dig into your material and actually create that. And think of CAM software. I mean, our NC files, which is numerical code, it's called a lot of different things with a lot of different machines, but that's the general term. It's a ton of points in space. And the tool is basically connecting the dots in space. And then the post processors that we spoke about, that kind of translates it to a language that specific machine can understand. So behind the hood, when you click that magic calculate button, that's what's going on. That's what your computer or your CAM software is thinking about, and it's generating hundreds of thousands, if not millions, of lines of codes, which is basically number one, machine language, saying, hey, pick up this tool, pick up that tool, spin it at this many RPMs, and then most notably, it's just a bunch of points in outer space, which the tool just tries to connect.
So a design of a crown, according to the software, is covered in points, and they're all connected?
So we use the surface of the STL file, which is a triangulated surface. We're the ones who basically, in virtual space, drag that tool along the surface of that part, and we create those points.
Oh.
Because the points is exactly what the machine can understand. It has a coordinate system, and we tell it exactly what the coordinates of each of those points is, and it just continues to blindly follow our instructions. So a machine without CAM software is just a huge paperweight, and CAM software without a machine is just the most boring video game ever. So
the software is in charge, basically. It's telling everything what to do.
Yeah, a good analogy that I've used in the past, and it holds true in many aspects, is that the machine is a car and we're simply the driver. So as you make your way around a racetrack, we tell you where to slow down, we tell you where to turn, we tell you where to speed up. We're basically controlling everything, including the RPMs of the engine and manipulating the car in every way that we want to get around that racetrack as quickly as possible. Or that might not be the goal, but nonetheless, getting around the racetrack is the goal. And we're the driver in that situation.
With all of the different milling machines, how do you connect the software to each machine?
Yeah, generally each machine is, I mean, especially in the dental world, is a similar size, similar kinematics, which is basically 5 axes, right? We're dealing mostly with 5 axis machines these days. So there's similarities between the entirety of the machines that hit our market. Obviously, a lot of them are oriented slightly differently, so an axis might be flipped. You might, when we tell an axis to spin one direction in one machine, that same command might spin it the opposite direction in the other machine. So to give credit back to our German counterparts, they find out, or they communicate with the machine manufacturer to learn all the information about their specific machine in order to build the files in order to upload that when it comes to operating that specific machine. What our specific branch office in North America is tasked with is creating a database of toolpaths and tools in order to basically prescribe every parameter that is required in order to mill the materials and applications that are necessary for that particular machine. Easy enough, right?
That's got to be so ridiculously hard.
You're referring to a tool as the burr, right?
Yes, that's right.
And then the path is the computer's instruction on how to use that burr to make whatever it's designed to make.
That's right. That's right. We tell it exactly where to go, how quickly to do it. Let's pretend we're dealing with a pretty robust machine with a really powerful spindle. We'll tell that tool during roughing that it can go much deeper into the material because that spindle is more capable of hogging out significantly more material without breaking. Maybe the tool itself is also a larger diameter. That means we could be even more aggressive with that. So we say that you go, X amount of millimeters deep with the tool, and you move it through the material at 3,500 millimeters a minute, which is the speed in which we use. That's called the feed rate. So,
but how does it? I mean, if a lab went and switched burrs, it has to tell this system which burr you're using, because if it has a different aggressiveness or a different size, it's got to know that, right?
That's right. So we draw the entirety of each tool up in our software. So we have the profile of every single tool, and then we associate certain parameters with each one of those tools.
So every time a lab changes a burr brand, let's say, it's got to go in there and change it on the software. And if it's not in the software, they either can't use it or you got to come up with the profile for it.
That's right. If a tool, now we're getting into some of the nuances. I like it. So if a tool from a new manufacturer has the same profile, the same dimensions as the original tool, let's call it the OEM tool that came with the machine, then they could just swap those out, no problem at all.
Get it, yeah.
If the new tool actually has some additional reach or an additional length to it, that's actually okay too. You can't utilize the entirety of that reach because it isn't drawn up in our software, but at least you're not going to have a situation where the tool is too short and then it's going to start rubbing against your part, rubbing against the blank, or even worse, colliding with hard parts within your machine.
Yes, I've seen that happen actually.
Not
good.
Not HyperDent.
Well, I have no idea. Well, I think it was a dent supply mill, but anywho.
The lab itself can screw up, correct? If they don't have the right tools, or they don't listen, or
they can, and they do.
Error?
They do.
Yeah.
That's what we're here for, to help them find out what mistake they might have made, and it's understandable. There's a lot of things happening. Not only when you get a new piece of equipment, but then all the ancillary products, right, that are associated with it. To think, oh yeah, this website is trying to sell me a tool that's a little cheaper, and maybe it will work just as well if it was drawn up appropriately in the CAM, but it's not. So I'm just going to bring it into my lab. I'm going to give it a quick test. And then sure as hell, it just starts, running into the corners of the blank or rubbing into the part itself, knocking it out of the blank. And that's where, you would need to draw it up correctly in the CAM software.
That's where they call you guys and say, what did we do?
Yeah, I say go back.
They call you and say, your CAM software messed up. And they don't take blame.
Of course.
Well, I'm sure we do probably try to cut corners, but I think with the software itself, it's basically telling you can't, or they've got to call you and let you know, can I not use this new tool?
Yeah, for sure. I mean, jokes aside, I love when people try to test new tools, new materials, but there is a correct way to do it. And you have to understand a lot about what's happening when you start to throw different types of tools, different types of materials into your machine. There's a lot of stuff that went into making whatever solution you bought work well. And there's probably a way to make this alternative solution also work well. But it's going to take a little bit of not
It
just
ain't gonna be
simple.
easy.
Yeah, it's not going to be, hey, call this material, this new material we've never milled before. It's kind of similar to PMMA. Just call it PMMA and let's see if that works, right?
Yeah.
Yeah. And that's how we roll.
Of course.
We're going to try to get something by you, or you've got that young person in the mill and they're messing around and trying out new things and not working.
Yeah, I love the enthusiasm there, but these are very heavily vetted out solutions. We have a ton of these machines in our office. We have a tech center in New Hampshire, and a lot of the machine tool partners have sent us equipment in order to validate solutions. A lot of the material manufacturers has utilized our implementation and our integration services. So they'll send us a material. It's quite different in terms of its characteristics than anything else that's been used before, and then they'll utilize our services in order to implement the entirety of the templates to mill those materials and distribute them amongst the HyperDent user base.
So when you're mentioning material, we have to compensate the cam for material, meaning like even different brands of zirconia, I'm sure, have different densities. I don't know.
Different zirconias act pretty much similar enough, let's say, in most situations. Okay. Yeah, there's a few outliers there, but in general, different brands of zirconia, it's especially now that we've matured so much in this market, are acting generally the same in the green state, especially. An example of a material manufacturer that enlisted the help of our services was HosBio and their new amber pucks. The reason that was a unique application is because unlike milling, Emax or any sort of glass ceramic product is ground, right? So you don't use a tool with cutting edges. You use basically a solid stick of carbide with diamond coating that grinds away at the material.
Interesting. I did not know this. No.
Yeah, and that's why you have to wet mill it, because that actually generates a ton of heat. So the challenge that they've presented to us is, with ingots or with blocks of glass ceramics, you could come in from the side and just start shaving away material. That's the best way in order to use a grinding tool as opposed to a milling tool. A milling tool, you could just come in from the top and then take some Z-level plunges or start to get down into the material in it more as you've seen milled in any zirconia crown, right?
Sure.
So the challenge that was presented to us is that now we have glass ceramics in a disc form or in a puck form. How do we start shaving the side of it, right? So we generated a cool new toolpath. It was actually designed for something else, but we were able to implement it, where we take this grinding tool and we spiral down to the very top of the crown, basically just making a small hole in the material, and then we immediately just start to finish the surface of the crown. So then we start working our way outwards, and it's very similar to the way that we shave the side of an ingot. And
it's kind of nice grinding. Yeah, I see.
Exactly. So you start grinding away at the sidewall. And interestingly enough, you're taking such a small step over where it's not putting any sort of significant lateral load on the spindle itself. So the tools last pretty long, and we've had a lot of success with it.
Is that why Emax and all other lithium disilicates don't come in a puck? Is all because of the milling?
Up until recently, I think maybe. I don't know. Maybe it has something to do with the way it's manufactured as well. Maybe it's easier to put it in small little ingots like handle. That. Maybe it dates back to the way that the original Cyric machines just started to make their way out into the world, and everyone just copied them. I'm not sure about that.
Do they have Emax pucks now, or lithium disilicate pucks?
So HosBio has started to create amber in puck form, and that was the company that hired us in order to implement or do some testing on all the machines that we have in our office. Because we do have a really wide range of machines, which means if we could do it on the 5 or 6 machines that are in our office, we could translate whatever we learn from that to almost any other machine that we cater to on the market.
That's cool.
So that's how, wow. So they brought it to you so that you guys could trial and error it a little bit, research and develop?
Yeah, we broke a lot of tools at the very beginning stages. We burned through a lot of amber material, but we've successfully delivered a database to our distributor network. DOF is one of the companies that was an early adopter of it. They just threw a bunch of beautiful photos of what it is that they were able to create out of those amber pucks on their social media.
That's spectacular. That's exciting.
What would have happened if you didn't figure out a way to mill it? Like, would they just be like, well, I guess we can't sell it and be done?
I mean, I would hope that they did some of their own testing over in Korea. I believe it's a Korean company before they decided to mass produce it. That's a good question. It often happens where a lot of people invent some sort of a new screw type or a new restoration type, and maybe they could print it because printers don't have the limitations of axis limits, and bend. In some cases, you would technically have to bend a tool around a corner, which is impossible, right? So we really appreciate when people come to us in order to hash out some of these challenges before they start to release products into the world. Many have learned that that's the best course of action.
Yeah.
Well, many others have not. So they usually come to us in a minor panic with a release product in the world, or at least what they thought was a release product, and say, hey guys, you really need to help me out here. And we try to oblige. So
yeah. You heard it on the podcast. Go to these guys before you release the material so that you can figure out how to do it correctly and develop a CAM software to launch before launch.
That's right. Yeah. And luckily we have a bunch of really smart guys on our team. Our engineers are super sharp, and we would identify potential issues outside of just, how the tool or what tool types are necessary, what challenges we might face. Speaking of Preet, Elvis, I know you said that's exactly where we originally talked about getting my butt on this podcast. They just worked with us in order to implement their preforms, which includes angulated options, which are pretty cool, into IMUS machines. So yeah, we had to work with a local machinist in order to design and create a fixture to hold them in an IMUS machine, and then we created the calibration routine and then all the toolpaths that went along with the implementation of that too.
So using that as an example, so Preet comes to you with the idea, we want to mill blanks with angled screw timbers. How long does it take you to figure that out? I mean, has this been in the works for years, or?
So they created the general solution on the CAD side.
Yep.
They also created the blank type in which it allowed for the angulated screw channel. And
before they knew you could mill it. Sorry, I'm just fascinated that people develop product before they know you can do anything with it. Okay,
some weird. That's for sure.
I bet a lot too.
The Preet guys are pretty sharp too. So yeah, we were able to work with what it is that they provided us, and there weren't too many challenges in what it was that we were trying to accomplish.
But how long did it take for you to figure it out and get it out there?
Is that including or not including the FDA's intervention within this whole process?
So you have to do it FDA?
No, that was
side?
Oh, FDA.
Yeah, that was something that Preet had to manage. That added to our timeline significantly. We had to do a lot of extra validation parts for those reasons. But in general, I mean, if we just sat down with a fixture that was able to hold their blanks, this is just a couple days in front of a machine, making sure that it's working right. All the other parts that need to come to fruition too, like actually working with the local machinists that we've worked a lot with on these types of projects in order to create that. I mean, that takes a couple weeks too, but once it's time to actually implement it within HyperDent, it's not such a long process.
Interesting. And it's just all code, right? You're just saying, oh, we need this tool, this burr to turn a little faster for this longer, and you write that into the code and you just trial and error?
Yeah, luckily the tool that our German counterparts made available to us to generate this code, called Template Generator, is pretty easy to use for someone who's slightly familiar with machining. So it uses dental specific terms. So our toolpath is called margin line finishing. It's not called some obscure, industrial using some obscure industrial verbiage or something like that.
Yeah, some German word you got to look up. Yeah, I get it.
Exactly, yeah. And there's drop down menus. I mean, it's like, which tool do you want to apply to this particular tool path? There's a drop down menu, and it has all the tools within the library. You want to, if you want
Oh,
to take a tool
interesting.
path
Yeah.
and move it before or after another tool path, you just simply click and drag it above or below it. Yeah,
And
so
drag it. Oh,
yeah, that's actually
interesting.
part of the reason that I was drawn to the software. It made it so much easier for me at Datron in order to support my customers, because I had the ability, and I didn't have to outsource, some obscure implant type or something, right? I had the ability to create those resources for our customers myself.
Is this how things all of a sudden can be milled faster? I've seen this, and we had an ad from another company. I don't know if they use HyperDent. It doesn't matter. But they're like, all of a sudden we can mill these things 30% faster. And I'm like, well, how did that happen? How all of a sudden? Is it just rearranging the order of things?
No, there's probably a few things that happened. Maybe the CAM associated with that particular application, maybe they developed a new toolpath that was specifically for whatever unique feature was on that part type. Maybe they introduced a new milling tool that is stronger, bigger. So if the machine already had the capability with, a large, powerful spindle, but it was utilizing smaller tooling, you could only take a 2 millimeter tool and move it through material so quickly until it simply breaks, no matter what machine you're doing it on. If they
Yeah.
potentially, if you double the size of the tool, you could more than double the machining time in that regard.
But this almost sounded like no tools were changed. It's like they just flipped a switch in your mill.
Mm.
Is that possible? Or maybe there are. I don't know.
It could have been maybe just a conservative milling strategy that they tested. They learned that they could do something a little faster than they previously prescribed.
Has HyperDent ever done this?
We try to be pretty efficient right out of the gate. Of course, we need to balance the fact that there's thousands of HyperDent users. We can't toe the line on every single parameter, but we also appreciate the fact that every machine has a certain capacity, and we don't want to take all day doing everything for these particular customers, right? So yeah, we have some options in our templates. It's just like we spoke about template editor light, and that gives the customer a little bit of control. And what it could do is potentially give them a range of parameters they could follow. So if you want to sacrifice a little bit of the surface quality for a faster milling time, then you have the ability to change those settings in HyperDent.
Oh.
We give you a top and we give you a bottom limit, so you can't screw anything up too badly, but we give you that freedom in order to make changes within that range.
So what is your HyperDent customer service like? Do you have like a whole bunch of people where if a client has a problem, they can call you and get an answer right away? And are you able to get into their system?
Or is it just you?
Just me sitting here, yeah.
Or is it just you?
He calls me. No, so we are able to stay a little smaller because we've enlisted the help of our distributor network who takes on the first level support. So our main role is to support the escalations from many of our distributors who can't figure out what it is that might be going wrong with a particular customer or situation.
Yeah.
So you're the big dog. So then you're through like different companies that sell HyperDent, and then they're the ones that are the troubleshooters?
Yeah, so let's pretend, that there's a simple error, a new user that just got trained and they're having trouble like tilting the part to make it fit within a blank. Yeah, that's something obviously, well, not obviously, but the entirety of our distributor network would be able to take that call and help them out. Now, if they were...
Yeah, call NOAC.
There you go. If they were having some sort of collisions, which we spoke about earlier, maybe they threw in a new tool. It's hard to diagnose the fact that the shank is rubbing against the part. That's why it's falling out of the puck. That might be something that they would take to us.
Okay.
Yeah.
So that each distributor gets trained by you guys to be able to help the ultimate customer.
That's right. And they have access to us.
And then whenever it rounds up or something really crazy, it goes to you guys like one-on-one.
Yep.
So are you constantly like redoing or upgrading the CAM software?
We iterate as much as we can. We try to stay current with what it is that our industry is asking us to create on these machines. A good example of that is a few years ago, everyone switched from full arch restorations with tie bases and started to
Yep.
do more direct to multi-unit type stuff. And this is an example of what we spoke about earlier. Everyone's starting to design these parts differently, and they forgot to come to us and say, "Hey, is this machinable?" And
Yeah.
and through over the past few years, we've created a whole new line of milling tools in order to cater to the specific challenges of direct to multi-unit restorations. With tie bases, it was a through hole. The screw axis hole was a through hole.
Yeah,
You had
just a
access.
hole.
You had
Yeah.
access to the top. You had access to the bottom. So tool length wasn't an issue.
Yep.
You could attack half of it from one angle, half of it from the other. But when you have a screw seat area in a direct to multi-unit restoration, you could only access that from the occlusal side of that screw channel. So not only did we create a slightly longer tool in order to do that, but we also created that same tool with a flat bottom so that it was able to mill that screw seat area.
But now there's like 400 different screws out there for these things, and they come in all different shapes and sizes and heights and the head height, and you got to have a path for all of them, right?
Yeah, we have a long list of screw manufacturers that we've worked with in order to bring their screws into our milling center or our tech center here in New Hampshire and figure out exactly the result they're trying to accomplish. And then we utilize a pretty cool feature that I was familiar with all the way back in my Datron days, because it was traditionally built for milling titanium bar interfaces. Or just single abutment interfaces. We used to mill abutments directly out of a disc back in the day before the FDA got involved.
Oh yeah.
Really? That's interesting. I never knew that
before the FDA got involved.
I never knew anybody milled the interface. That's exciting.
Yeah, and I mean that Datron machine was more than accurate enough to handle the accuracy required to mill those parts successfully. But now everything shifted over to preforms, which absolutely is more consistent. Those are made on a Swiss turning machine on a lathe. It's the type of machine that can create a high volume of those parts and maintain that accuracy that's required on the amount of parts that are necessary to pump out, hundreds, if not thousands of preforms.
But that same technology, you're doing it with metal bars. You're now doing it on zirconia.
Yeah, so we call it implant module light because it's catered specifically to PMMA and zirconia machines, which are more light duty machines. And back to the tools that we had to implement in order to accomplish that, we also had to create a line of T-cutters, and they're shaped exactly like they sound. They come in from the cavity side in order to mill a screw seat area, as opposed from the occlusal side. So they kind of sneak around the corner in order to mill that screw shelf area, because on an angulated screw channel, that tool coming in from the occlusal side doesn't have the ability to mill a flat screw seat, right? So our first option would be to go to every single machine manufacturer and say, "Hey guys, here's a need, and here are the dimensions of the T-cutters in which we suggest you manufacture," and then they're all going to have to go and manufacture them. Alternatively, we worked with a tool manufacturer here in North America, and we had them create it for us. We never intended to become tool distributors, but that's what we had to do in order to make it a complete solution that can be used universally throughout all of our machine types that we cater to.
Do you ever hear some of these companies kind of come up with these ideas and you're just like rolling your eyes like, really? You want to do 80-degree screw correction or something? You're just like, let's slow down here for a second.
To be fair, we love challenges. It also helps differentiate us from our competition because we're pretty good at addressing what is typically something that maybe they aren't able to do.
Yeah.
So yeah, there's a lot of crazy stuff going on out there. And like I said, we like a challenge, but we're making fun of you on Teams in the background. Don't you worry.
Yeah. But I mean, they come up with the crazy ideas, but you guys have to make it happen.
That's what I'm saying. Are you just like,
right?
Seriously? Again? Really?
I mean, like, that's got to be a tough thing to do.
Yeah, we weren't as good at saying no previously as we are now.
Now you kind of know it's crazy.
That's right.
You're like, no.
We're able to identify that pretty early on, and hopefully we could articulate that to whoever is trying to do something that's just beyond the limits of physics. If they can't understand that, then they're going to be mad at us either way. So we'll just say, hey,
that's
sorry,
good
no
call.
thanks. You're going to be mad at us anyway. But but maybe reinvent what it is that you're trying to accomplish there.
So when somebody buys a mill, you mentioned competition. You're not the only one in this space. Do you get to choose what you want to use? I don't even know how this works. I've never personally bought a mill.
Yeah, that's a good question. There's a few things. There's some distributors that carry a variety of CAM software products, and they would give you that option.
Okay.
In many cases, the best CAM software is the one you're already familiar with. If you're trying to do something pretty complex or very specific, especially when you start making your way into the direct to multi-unit world, hybrid manufacturing, we're doing some special stuff with dentures in the very near future. If you're trying to do anything that's one of our areas of expertise, then I'm hoping that those distributors would guide them in that direction. There are a few keywords that a prospect might say in order for them to perk up and go, oh, okay, well, that's an easy decision. That's a HyperDent purchase, and here's why. But a lot of our distributors are exclusive to us, and that's because we've done a good job training them. They're familiar with our product. They're able to support it well. So fortunately for us, they might say, hey, I appreciate that you have used or have heard that this other CAM software might be what you want. Here's why HyperDent is what we will provide to you. And if that's not agreeable to you, then I'm sorry, we can't help you. We can't support you if you're using a CAM product we're not so familiar with. Those are the relationships we prefer. But in an ideal world, that's not how it always comes to fruition.
But do the mill companies even care what's on there?
Some do, some don't. Some people just want to, or some mill manufacturers just want to get the highest quantity of their machines out into whatever territory they're trying to get into. And some mill manufacturers appreciate what it is that we add to their product, and they're supporters of us as well. And they'll fight that same fight that a distributor like we just spoke about would fight when it comes to explaining what it is that benefits them, the customer, by pairing their machine with HyperDent CAM.
I love it. It's foreign to me, but yet it's very recognizable because it's there.
Yeah, we're really a niche within a niche, right? I mean, the dental tech industry is enough of a niche. Then you talk about mill manufacturing, right, or producing parts with mills. Then you talk about the software that runs them, right? So yeah, I get it. That's for sure.
Why it's taken us so long to get you on the podcast.
Yeah, right.
It's crazy.
I was trying to figure out what the hell we're doing for the last 6 years. I can't explain it to you, but I don't know.
We're asking you for timelines and dates and this and that.
Yeah, right. I've been successfully avoiding you guys for so long, and you finally got me.
Yay! So you're still in New Hampshire, though, by the way.
That's right. Yeah. So Datron, Datron is right down the street, a couple miles away from the Follow Me office. My wife works there. Still, that's where we met. Awesome. And that was one of the many reasons that I stayed in New Hampshire. I love it out here. I'm looking out the window of my office right now. It's this beautiful town square. The leaves are starting to change. People say when they come visit, they say it reminds them of the town center of Back to the Future, just a little smaller. So.
Oh, nice. Cool. Yeah.
Yeah.
Yeah. And who knew that a guy running all the dental CAM is in this little town square in New Hampshire?
Yeah, right?
Yeah.
It's insane.
It's the dental CAM capital of the country in Milford, New Hampshire.
Who would have thunk?
Love it. Yep.
Yeah.
Real quick, you mentioned dentures. Has that whole industry changed how you've done things, or it's a whole different milling, I would imagine, not so much sharp edges? I don't know.
So forgive my lack of experience in what makes a good denture, but from what I'm learning is that everyone started to print their dentures, and that wasn't a suitable enough option for many, if not most people. They're coming back to us to say, hey, and correct me if I'm wrong, that the materials that can be used within a milling process for dentures are way superior than the materials that you're using in terms of the printing process.
Yeah, I would agree.
I'm looking at a milled denture right now on my desk, and it already looks polished off of the machine.
Yeah.
It was a pretty robust mill that produced this one, and it used a wet milling technique, which also helps polish the surface of a denture.
Interesting.
But it looks amazing right off the mill. And yeah, that's a direction that a lot of people are heading back to, or they're investigating the options in which they strayed from earlier. Also, the machines are getting better. They're getting a little tougher. So there's a lot of material that you need to remove in order to get a denture out of a pot.
God, yes.
Yeah.
No doubt.
And the machines that are capable of doing that, and it doesn't only mean that we're using big fat tools and powerful spindles. It means we're also just smarter with the templates in which we utilize to produce these parts. But even the smallest of benchtop mills can get a really high quality denture off a machine in a couple hours.
Really?
Yeah, the project that we're working on right now is with Ivotion or with Ivoclar. Their Ivotion dentures are going to be available within HyperDent in the very near future. Before the
Oh,
What?
good for you guys. That's
I thought
great.
you had to do it in a PM7.
That's exactly right, and they're opening up
Branching
their
out.
solution into
That's great.
third-party solutions, and they've chosen us to partner up with in terms of validating that. It's going to start with iMills, which is a machine made by Imagine USA, and Roland machines, the 53 series. So we've already
Nice.
done a lot of testing on both of those machines, and we're getting really good results. So there's two processes that they've licensed to us. One is the Ivotion process, which is that clamshell, half tooth colored, half tissue colored.
Oh yeah, that's some crazy stuff. Yeah.
Yeah, and the alignment of that within the machine and the result of that right off the mill is pretty impressive. Yeah, we've been happy with those results.
Wow.
And then their other process is what they call the oversize process. It's 2 steps, well, 3 technically. You mill the denture base. You leave it completely unfinished, but you mill the tooth pockets to completion. Then you mill the teeth, and you leave the occlusal side of those teeth completely unfinished, but you mill the interface of those teeth with the tooth pockets to completion. You take that out of the machine, you put them together, you throw it back in the machine, and then you mill the entirety of the denture in one shot, and that yields a perfect occlusion.
Yeah, that's cool.
Yeah.
And speaking for the industry, your job is to get those dentures milled in about 10 minutes.
Yeah. 10 minutes.
10 minutes. No problem.
10 minutes.
Yep. Yeah, that's the biggest thing with the milled dentures is they just take too long.
Yeah. Well, we already talked about defying physics, so I'm not going to go back into that.
Yeah. Come on, you can do it. Jordan, this is fascinating stuff, man. Thank you so much for coming on and explaining what CAM is and what HyperDent is, and I love it, man. Thank you so much.
Thanks for having me. It's definitely not going to be another 6 years until I reconnect with you guys.
Yeah, no doubt. We got to have an update soon.
Oh, for sure, yeah. I'm glad I could be your cam guide in this confusing world of nesting.
We didn't even get into nesting. Jesus.
Yeah.
All right, we'll save that for part 2.
Yeah, part 2.
Yeah, no,
Thank you.
traditionally, that's what everyone just assumed cam software was, right? Is just placing the parts in the puck. They didn't know all the magic that was happening in the background. So
I didn't even. We'll definitely save that for part 2.
awesome.
All right, Jordan, man, we appreciate it, and have a good
day.
weekend, and hope you feel better.
I appreciated being on your show. You guys are awesome. You guys are the best.
Talk to you soon.
Yeah, thanks. Bye-bye.
A huge thanks to Jordan for coming on our podcast and explaining to Elvis and I what the heck CAM software actually does, which honestly, I kind of had a rude awakening, and I get it now. So, guys, we spend a lot of time and money to get the best software, the best materials, and the best equipment. Why not get HyperDent to take it all to the next level? Remember, the parent company is Follow Me Technologies. So, head over to follow-me-tech.com to learn more and to see if HyperDent can maybe fix that issue you have been having. Can you hear my dogs? Sorry.
I do hear your dogs. Jesus.
Can you hear them? Can you hear them?
They sound like demons.
HyperDent can maybe fix that issue that you have been having, but just keep thinking you need new burrs or a better design. So, worth looking into. So, thank you, Jordan.
All right, everybody. That's all we got for you. It sounds like Barb's going to be eaten by her dogs.
Yeah.
Have a good one.
Have a great week, guys.
Bye.
See ya.
I'm good. I'm sitting in the closet, Barb. The views and opinions expressed on the Voices from the Bench podcast are those of the guest and do not necessarily reflect the official policy or position of the host or Voices from the Bench, LLC.